Hey everybody, last conic section, the parabola. Now you kind of already know a lot about a parabola. You especially know about this first one, the vertical parabola, the up and down. We know that as the parent function y equals x squared. You know there's a vertex, you know there's an axis of symmetry. We are going to actually graph these kind of differently. So we're going to graph it obviously the conic section style, so it does have a different feel. But we're going to start by just going through some of these parts of this parabola. The main point is the vertex, and the vertex appears in the equation, so we can find the vertex pretty easily. The point that's inside this curve is the focus, and this line that is outside the curve is called the directrix. And both of these are P away from the vertex. So we find P, you count into the shape for the focus, you count out of the shape for the directrix. The directrix is a line. And then we also have another line, the axis of symmetry, which this is drawn right on the y-axis, but that's your axis of symmetry. When the parabola opens up left or right, remember the focus is in the interior of the parabola. This would be the vertex. This line out here would be the directrix. And again, that space between the vertex and the focus is P, and the vertex and the directrix is still P. P appears in the equation. So again, the focus always lies inside the parabola. The directrix is outside the parabola. It directs it away. And then your two lines that you're going to draw, they're kind of not really part of the graph. The directrix and the axis of symmetry, they're always perpendicular. And so when we draw these are going to, one's going to be y equals a number, the other one's going to be x equals a number. The vertex is P units away from the focus and the directrix. So those are all the things that I said, and hopefully having them written down there helps you a little bit. So let's go through what the standard form looks like. If the parabola, and obviously I can't see it anymore, but this is the vertical, so if it opens up or down, we know that this means y equals x squared. We already know that from their parent function. So it's the x that's squared. So just like a circle, we have x minus h. But now, that's obviously still squared from a circle. On the other side, we're going to have 4p and then y minus k. And then this side is not squared because it's a parabola. Only one side is squared on a parabola. If the parabola goes left or right, then it starts with, we want the y to be squared. So it's y minus k quantity squared is equal to 4p times x minus h. Now the side that you have squared doesn't really matter if it's the left side or the right side. What matters is this number is in front of the side that is not squared. That number tells you kind of a lot of stuff. If p is positive, so it opens up if, that's a weird if, p is greater than 0. It opens down if p is less than 0. For the left and right opening parabolas, this is the y squared parabolas, it goes right if p is greater than 0, and it goes left if p is less than 0. Again, because negative numbers are to the left, positive numbers are to the right. In terms of graphing this, you're going to put the vertex on there. We're going to count the squares to find the directrix and the focus. But this part right here, oh, I'm not sure what happened there. This part right here is super, super important. I'll put a little box around it. Let's highlight it. So the width is actually 4p, but that's the width at the focus. And I'll show you what I mean when we draw the graph. So I'm asking you to have 3 points plotted. Exactly, not eyeballed, not just sort of drawn in there. Please plot 3 points. You can plot more than that if you'd like, but I'm asking that you have 3 as a minimum. So the vertex and 2 others is generally what happens. And I'll show you how to get the other 2 without really doing too much work. If you can solve for y, you can put it in the calculator if you'd like, but I'm going to show you how to do all of this without the calculator, since about half of them you can't do the calculator anyway. So for the vertex, we want the opposite of x, right? So x is obviously right here. So, and then we want the opposite of the y. So 4, -3. That feels like everything we've done. Circle, hyperbola, and ellipse. They all feel that same way. So I'm going to put that on my graph. I don't know what happened to this picture, but sorry. 4, -3. I'm not sure if that's right, but it's definitely close. Now what we're going to do is we're going to use the 2. So we know that that number represents 4p. And this, for this first graph, this is not that easy because the numbers are so small. So p is 1/2. So that means, kind of obnoxiously, we have to go 1/2 space up because this is x squared. P is positive, so we know it opens up. So 1/2 space up is your focus. So if you imagine we're at -3 and we're going to move up 1/2, we'd be at -2.5. So that's the y value for the focus. So we go right 4 and we go down 2.5. But kind of more importantly, that's where the focus is. And since p is, since the number in front was 2, this 2 right here in the equation, that's how wide the graph is. So from the focus, we can go 1 right and 1 left, and that is the exact parabola. I'll keep doing that over and over again. So the line right through the focus, 1 left, 1 right, because we're talking to go a total space of 2, and we can draw that in there very, very easily. Now for the axis of symmetry, that is the line that kind of connects everything, right? It runs right through the vertex, it touches the parabola, it touches the focus, it touches everything. This is a line, and you can tell that it touches the x-axis at 4. So this is the line x = 4. Now the directrix is also a line, but it's outside the parabola, and it's p away. So we're supposed to go 1/2 space away. We're already down at -3, and so it's going to go this way. You can't really draw it on there, at least not accurately. So this would be y equals, because this one touches the y-axis, at -4.5, because we had to go down 1/2. Really hard to see, but that's the process. This one will be a little bit easier because we got an 8. The bigger the number is out in front of the side that's not squared, usually the easier it is to graph because it's just bigger. And so then, of course, then I have a 16 in the next one. So it gets better. So let's start with the vertex, xy. So the vertex is 0 because there's no number here. 0, -2. I'm going to put that on the graph. This is y squared. Y squared is either left or right. It's determined by the p. So 8 is equal to 4p. So we get 2 equals p. So it's positive. So now we know it goes to the right. So all we're going to do is count the spaces. 2 spaces to the right, that's your focus. So it looks like the focus is at 2, -2. 2 spaces outside there is this line. That is your directrix. And that is the line x = -2. The axis of symmetry joins them all, touches the y-axis, yep it does, at -2. I just feel like I keep saying the word axis. Now the graph. Right through the focus, so right through here. We're trying to make it a width of 8, so we're going to split that up. We're going to go 4 up and 4 down, right in line with the focus. And that's how you graph the parabola. You don't need to plug any numbers in. You don't need to use the calculator. You can if you want to, but you have to be able to solve for y in order to use the calculator. And generally, left and right opening parabolas is hard to solve for y, so I would not suggest it. You can try it, though. So let's do this one. Then we'll do them kind of backwards, I think. Or no, we'll do standard form. So again, the vertex is x, then y, so 5, 1. That's our vertex. I like to label it because I forget sometimes. And then we need the value for p. So -16 is equal to 4p. So it looks like -4 is the answer for p. So this is x or y squared rather, so it goes left or right, but now we know it's negative, so this is left. This is hard to read, sorry. So we know that -4 is the answer for p. But the whole thing is going to be 16 wide. This thing is really wide. Basically, the larger the value for p is, the wider the parabola is. So since it goes to the left, 4 spaces to the left is your focus. And the focus would then be at the point, looks like 1, 1. 4 spaces to the right, which is kind of not on the graph, is where the directrix would go, right through here. So this touches the x-axis at 9. The axis of symmetry connects them all as this line here, and that touches the y-axis at 1. Now, to draw the graph, we're trying to look at the 16. I know it's negative, but the negative controls the left. So now we're just talking about the 16. So we're going to take 16 and we got to split it up evenly. So we're going to go from the focus, 8 up and 8 down. It kind of almost doesn't fit on the graph. So it should be up at 9, and this, I think the grid only goes to 8, and then down to 8. -8, I guess. From the vertex, that's why I label it, because I always draw from the wrong point. You're going to draw your parabola. That is a super wide parabola. They're not normally that wide, but it's obviously a little bit easier. Now, for standard form, I'm going to keep whatever is squared on the left. You don't have to do that. You can put whatever squared on either side. That's irrelevant. The parabola doesn't care. But I'm going to be consistent just to warn you. So I'm going to keep that y squared there, which means the negative, or the 12x gets moved to the other side, and the 24 gets moved to the other side. So now, with parabolas, you have to factor. So we're going to take out the negative 12. This leaves it with x plus 2. And that's all you got to have, right? Because we want a number in front of the side that's not squared, and we want the other side to be squared. So we're good. Now, this is y squared, so it's either left or right. You can tell that this is a negative number, so that means it's going left. Again, I'm going to keep the stuff that's squared on the left. That means 2x, 20y got to go, 61's got to go. So negative 20y minus 61. Now we have to complete the square on the side that's squared. I'm just going to make some space so I can do that. So half of 2 is 1, and 1 squared, we're going to add 1 to both sides. So this is x plus 1 quantity squared. That side is done. Over here we might have some work to do. Negative 61 plus 1 is a negative 60. So on the right-hand side, remember you want a number in front of the parentheses. Sometimes that number is a 1, but in this case we're going to factor out a negative 20. Leaves you with y plus 3. So now we have x squared, so it either goes up or down. You can tell that that number out in front is negative, so this means it goes down. Last one. Again, I'm going to keep that y squared on the left. And so that means the 14y has to come over here and join it. So we have, that's a y squared minus 14y. Negative 2x is going to get added to the other side, and the negative 45 is still there. Now we do have to complete the squared. So I'm just going to set this up again so that I have room for that. This is a minus 45 plus blank. Half of 14 is 7. 7 squared is 49. We're going to add 49 to both sides. This is y minus 7 quantity squared. On this side we get 2x plus 4. It is the side that is not squared that you have to factor. And it's usually just a GCF, which these two have a 2 in common. And now you can determine the direction in which it opens. It's y squared, so that's left or right. This number in front is positive, so this one goes to the right.